Welcome to today's lesson of third grade math unit 3. In this unit, we're going to talk about multi-digit addition, subtraction, and multiplication. Have your note sheet ready and your notebook. We're going to talk about a few things that are not on this sheet also. So you're going to want to make sure you take really good notes when you get to those portions of the video. Let's get started. The first thing we're going to talk about is place value drawings. Now, this should not be something that's new to you, but maybe you never fully understood it before. Remember that each place value is 10 times bigger or smaller than the one next door to it. So the reason we use a dot for ones is because if we line up 10 dots, it would make a stick, which is the tens column. If we take 10 sticks and place them all next to each other, we would get a hundreds box. And if we take 10 hundreds boxes and we stack them on top of each other, we would get a thousands bar. So the thousands is the rectangle, the hundreds is the square, tens is a stick, and ones is a dot. Some other knowledge you should have for words or number sense would be the different forms of numbers. Standard form means just the number form. So when you see just numbers, that's called standard form. The next one is expanded form. Expanded form expands out each place value. So if we have the number 982, we have 9 hundreds, we have 8 tens, so 80, and then we have 2 ones. And we would want to expand them out. Notice we only have one digit, and then we put zeros in as placeholders. The last one is word form. Word form is replacing all numbers with their words. Now, this is usually pretty easy because we write the words exactly as we say them. In this case, it's 982. Now, a couple things to keep in mind when you do word form. The first one would be that we need to add commas in anytime we see them in the numbers. So if this was a thousands number, let's say it had 1,000 in front of it, we would say 1,000 and then put a comma after the word thousand. The other thing to always be aware of is anytime we have a ones digit next to a tens digit, we have to put a hyphen in between it. A hyphen is that little dash in the middle of the air type thing. So between 80 and 2, you see a hyphen. This also goes any place value system. So if we have the 10,000s to the 1,000s, between the 10,000s and 1,000s number, you would have to put a hyphen. The only time you don't put the hyphen is when we work with teen numbers like 12, 13. Those numbers are just written a little bit different, so they don't use the hyphen. Otherwise, we put the hyphen in. The place value chart here would be a good thing to add to your notebook. It is wise to have this. Now, we're working mostly in the whole part at this moment in our math career, but it is important to start looking at the whole part of the decimal amounts. So we have anything after the decimals. Now, before we have ones, tens, hundreds. And again, this is where you would see a comma. And then we have 1,000s, 10,000, 100,000s. And then our next place value of millions, we'd put another comma there. We always have our repetitive place value system of ones, tens, hundreds, and then we have a comma. Ones, tens, hundreds, and then a comma. Ones, 10 millions, 100 millions, comma, then we'd go into billions. And we could keep going with the same pattern of ones, tens, hundreds, then we need a comma. If we read from right to left. Now, after the decimal, we don't have a place value called oneths. The reason for that being is, in theory, we count the 1 as the decimal point, and then everything after it is a 0. So in 10, we have 1 0, so it is one place after the decimal. Hundredths is 2 zeros in 100, so it's 2 spots after the decimal. And we keep going. The other difference is we don't put commas after a decimal because those are only parts and they don't represent whole amounts. But notice we have that THS, or just TH, at the end of each place value word. That tells us it's only a part, a fraction amount, and it is after the decimal. Addition. Now, you've been adding numbers since probably kindergarten, and so adding is not something that's new. However, we're going to just keep adding bigger numbers the more we grow in our math. So it's important to understand some different methods and models in order to do this. So the first method we have is the show all totals method. So we have 249 plus 386. So we added the hundreds. We've got the 200 plus the 300, we get the 500. And then we added the tens digit. 40 plus 80 is the 120. And then we add the ones digits. 9 plus 6 is 15. And then we can add them all together. Another method is new groups below method. This is where, as we carry over, we put our little amount down below. And then the last method, which is probably the one you're going to use the most often, this is the one that's taught the most often, is the new groups above method. In this problem, when you regroup, you always start on the right side, and when you regroup, you put the regrouping above. Now, what I don't like is when you put the regrouping as little tiny numbers like these examples show. When you regroup with that 1, make it just as big as the other numbers, because then you won't miss it. When you make those little tiny numbers, you have a tendency to miss them. Feel free to pause the video and give the example a try. Resume when you're ready to check. Welcome back. Let's check our answer. 8 plus 5 is 13. So we put the 3 down, we carry over the 1 next door. We have 1 plus 7, which is 8, plus 9 is 17. And we carry the 1 over. Again, notice I'm making my ones as big as my other digits so I don't lose them. 1 plus 2 plus 4 is 7. And we had no carryover, so our last number is 6. Now, in order to make this answer correct, we do need to put in our comma. Commas are important, especially in this unit where we're talking about place value. So we start on the right, ones, tens, hundreds, comma. Moving on to subtraction. We have a couple different methods of subtraction. We have the expanded method, so we can expand out 134 by putting the plus between the 100, the 30, and the 4, and expanding out the 58 by 50 plus 8. And then we can subtract each of the place value amounts, and then we add those amounts together. The next method is ungrouping first method. So this is where we know we can't do 4 minus 8. If the top is lower than the bottom, we have to borrow. So we are going to borrow all the way across right away. So our 3 becomes a 13, And then we got to borrow and we make it a 12. And then we make the 4 a 14. And then we can do our subtracting. Not as common of a method. It's more recommended to use the common US method, which is where we borrow only when we need to. So we could not do 4 minus 8, so we borrow from next door. We cross out the 3 and make it a 2. And then we make the 4 10 greater, so it's 14. And then we start our subtracting. And then we move to our tens digit. 2 minus 5 we can't do, so now we borrow. So we're only borrowing from next door as we need to. Let's give our example a try. Feel free to pause the video, try on your own, and resume when you're ready to check. Now this problem is a little bit more tricky. We have to borrow all the way over from the 7 to begin with. So the 7 becomes a 6, and the 0 becomes 10 greater, so it becomes 10, but we're going to have to borrow from it. So that's going to become a 9. Which makes the next 0 a 10, but we're going to have to borrow from it, and it's going to make the next one a 9. And then the very final 0 gets to become the 10. So we are going to have to borrow all the way across. Now we can subtract. 10 minus 6 is 4. 9 minus 5 is 4. 9 minus 4 is 5. 6 minus 3 is 3. And we put in our comma. Rounding numbers is the next topic. Now I'm going to teach you this a little different than if you watch any other videos, because when we start getting into rounding decimal numbers, the steps that I'm going to introduce will help you. The very first step is underline the digit you're rounding to. Then you're going to look at the digit behind and draw an arrow to the underlined digit. That number is going to tell you what to do. Now, here's where my saying is a little different. If your number is 0 to 4, you're going to round stay. If your number is 5 to 9, you're going to round up. Now, a lot of times you've probably heard in the past the term round down. In theory, we are making our number smaller when we would round, but a lot of times people get confused when they hear round down and they want to make the number smaller, since if we round up, we make the number bigger. So I like the term round stay. And then all digits after the underline turn to zeros. So let's take a look at the steps. We already have the underlined digit, so we're going to go to number 2. We look at the number behind it and we draw an arrow to the underline. The 2 is telling the 5 what to do. And if we look at our chart over here, a 2 would say round stay. So the 5 is going to stay a 5. Everything in front of it stays. Everything behind it goes away and turns to a 0. So our answer is 3,500. Now, again, this is why some people say round down. Our number did go down from the start amount, but sometimes that down term really messes up when our digit itself actually stayed the same. Okay, the next one, the 1 tells the 3 what to do. 1 is telling the 3 to stay. So everything in front of it stays. 1, 3. Everything behind it turns to zeros. So a 0, a comma, and 3 more zeros here. The next one, the 2 is telling the other 2 to stay. So our 2 stays. Everything behind the underline goes to zeros. Now this last one's a little tricky. The 5 is telling the 9 to go up. So the 9 becomes a 10. So the 0 is going to go here. The plus 1 is going to go next door into the next place value. Now, that 9 became 1 bigger. So this number actually became 1,000 because the 9 and the 5 became zeros based on rounding into the next place value. The next topic we're going to talk about is estimation. Now, in the past, you've probably heard people say, estimate how many candies are in this jar. And you'd probably just give it your best guess. Mathematical estimation is not guessing. It is using the skill of rounding. Whenever you hear estimation, or if you have a word problem that uses the word about, you are going to actually use rounding. So we can take a look at our examples here. 353 plus 89. Now, if I was at a store and I was buying some items and I wanted to make sure I had enough money, I probably am not going to add $353 and $89 together. It might just take me too long. So I might want to use estimation to come up with a quick answer. Now, in this case, we look at the highest place value they both share. The first number is in the hundreds digit, but the second number is only in the tens digit. So we are going to round these numbers to the nearest tenth. So 353 rounded to the nearest tenth becomes 350. 89 rounded to the nearest tenth is 90. So then I'm going to add those two numbers together and I get about 400. Notice that's only 2 off from the actual answer, but it probably made my adding a lot quicker. The next example shows that in subtraction, we have a hundreds digit and a hundreds digit. So we're going to round these both to the hundreds because they both share that as their highest place value. So 681 is going to round to 700. 291 is going to round to 300. And then I can do 700 minus 300 pretty quickly and get an answer of 400. The actual answer was 390. So my estimate is pretty close. And I know I did the problem right. The last topic I want to talk about is area model with multiplication. This is when we're working on 2-digit by 1-digit, 3-digit by 1-digit, 2-digit by 2-digit. Any type of digit that's bigger than 1-digit by 1-digit can use this method. Step 1, you're going to find the expanded form of the number. So we have, in our example here, we would do 300 plus 60 plus 8. And I'm going to make a box under that number. And everywhere I drew a plus sign, I am going to draw a line in that box. And then my 4 is not needing to be expanded, so I'm just going to put the 4 on the side. So now we're doing the area model, where we find the top number times the side number. So in this case, I have 300 times 4, the side number. So we can look at just our base numbers. 3 times 4 is 12. And I have 2 zeros that I forgot about there. Next one, I have 60 on top plus, or sorry, not plus, times 4 on the side. 6 times 4 is 24. And I forgot about 1 0, so I'm going to put 1 0 in. And the last one's 8 times 4. And 8 times 4 is 32. After I find all these partial products, I'm then going to line them up and add them together to find out what my true product of this answer would be. So make sure you line up place values carefully so that you're adding the right numbers together. And oops, that one should not have been 320. That should have just been 32. There were no zeros in that number. And I'm going to add these up. 0 plus 0 plus 2 is 2. 0 plus 4 plus 3 is 7. 2 plus 2 is 4. And 1 plus nothing is 1. So my answer would be 1,472. Make sure you pause the video and take some good notes on this concept. All right, at the bottom of your practice sheet, you should have some practice problems. All of these have been talked about in this video or in past videos, like the input-output table. Give it a shot. Resume the video when you're ready to check your answers. If you are struggling with any concept, rewatch the beginning portion of the video. Welcome back. All right, we have 3 boxes, which are hundreds, so 300. We have 2 sticks, which is tens, so 20. And we have 7 dots, which are our ones. So our correct answer is 327. Our next one, we're rounding to the nearest hundred. So we underline the 6. The 7 tells us what the 6 should do. 7 says round up. So the 6 goes up to a 7, and everything behind it becomes a 0. So we get 700. If the bookstore sold 293 books in the morning and 374 books in the afternoon before it closed, how many did it sell that day? And is a good word that means add. So we're going to add these together and we get 667 books they had that day that they sold. The next one here, we are going to make our expanded problem 400 plus 90 plus 1 times 5. 400 times 5 is 2,000. 90 times 5 is 450. 1 times 5 is 5. We add our partial products together to get an answer of 2,455. And the last one, our input-output table. We start with the number. Our rule is to add 10 to it. So 14 plus 10 gives us 24. 44 plus 10 is 54. 64 plus 10 is 74. And 94 plus 10 is 104. Please work on any IXL skill plans for grade 3, unit 3 to help with this unit. And don't be afraid to go into the Math Activity Center to work on any of the lesson checks. Rewatch this video if you need any more help. Otherwise, good luck.